Hello students, welcome to video lesson 4.2. Today we're going to start our more specific discussion on different polygons, specifically four-sided polygons, which we call quadrilaterals. And we're going to start today with the most basic special quadrilateral, which is something called a parallelogram. Okay, so a parallelogram is defined as a quadrilateral where both pairs of opposite sides are parallel to each other. Okay, so we have a four-sided shape here, and both pairs of opposite sides are marked as parallel. So this shape here is what we call a parallelogram. Should make sense why we call them that, because their sides are parallel, right? Two pairs of parallel sides make a parallelogram. Now, the key thing for today is four properties, okay? And we're going to go through the four properties of a parallelogram, and we're going to talk about what each one looks like in terms of in the parallelogram itself, okay? So property number one of a parallelogram is every parallelogram has not only the opposite sides parallel to each other, but the opposite sides are also congruent to each other. Okay, so what that means is this length from A to D is the same as this length from B to C. And the distance from A to B here, if I mark that with 2, is the same as the distance from D to C. That's this distance here, okay? So this distance and this distance are the same as this distance, right? So we have two pairs of congruent opposite sides. That's parallelogram property number one. Parallelogram property number two says not only are opposite sides congruent in length, but opposite angles all the way across the shape are congruent in measure as well, or in number of degrees, okay? So angle B down here in this corner is the same in measure as angle D up in that corner, okay? So those opposite angles are congruent, as are these opposite angles, A and C. These angles are also congruent to each other, okay? So A and C are opposite angles, B and D are opposite angles. Opposite angles in a parallelogram are always congruent to each other, which means they have the same number of degrees, same measurement, okay? Property number three says that consecutive angles, meaning angles that are next to each other or angles that are along the same side. So for example, angle B and angle C would be considered consecutive angles because they're both along this side. So B and C are consecutive angles, as are angle C and angle D, right? Angle C and D would be along this side. D and A would be consecutive angles next to each other. A and B would be consecutive angles. So all of those consecutive angle pairs add up to 180 degrees. Okay, that's actually a result of what we call the same side interior angle postulate back in chapter 2. So consecutive angles always add up to 180, or also known as supplementary, right? They are supplementary to each other all the time, every time, no matter what, okay? So angles next to each other always add to 180 degrees. The final property, property number 4, is that the two diagonals of the parallelogram, which are the segments that connect corners that are not next to each other. So for example, A to C, this would be a diagonal of the shape, connecting corners that are not next to each other. And then B and D also is a diagonal, the segment from B to D. Those two diagonals bisect each other. And remember that bisect means to cut in half or to cut in equal pieces, okay? So diagonals cut each other in half. So what that means is this distance from A to this middle point right here, this distance has to be the same as this distance here, okay? A to what I'll call M for middle point. A to M is the same as C to M. Those two pieces of that diagonal. Whoa, whoopsies. And then also B to M is the same as D to M, okay? BM is the same as DM. So I'll mark that here with 2 marks. So these pieces of our diagonals are congruent to each other, okay? because the diagonals, when they meet, they cut each other into equal pieces. All right, so that is property 4, that diagonals bisect each other. So that's the 4 properties of parallelograms. Of course, we also know that they have parallel sides because that's the definition of what it means to be a parallelogram. So all of this information put together is going to help us to find missing pieces of information in a parallelogram, okay? So, for example, if I had this picture and I knew this information right here, that the distance from B to H, so this distance right here was 21 units, you know, whatever it is, 21 feet or meters or miles or whatever. And they're asking me to find the length of BE. BE is from this corner all the way across to this corner, right? So B all the way across to E, that's the entire diagonal. So what we just have to think about is, how is the distance from B to H related to the distance from B to E all the way across? Well, because the diagonals cut each other in half, right, and H is where the 2 diagonals meet, B to H must be halfway across the shape, right? Must be halfway across that parallelogram, or across the diagonal, I should say. So the distance from B to E then is just simply twice as much, or 2 times the distance from B to H. 2 times 21 in this case is 42. So the length of BE is 42, okay, because it's twice as much as that half piece of that diagonal, all right? So that's one way that we can see a property at work. Another way is we can see this. This one's a little bit more complicated, so we're gonna have to sort of figure out what information are they giving us, what are they asking us to find. So here they tell me that the measure of angle HZM, which I'm gonna find first in my picture, HZM is this angle here. That angle is 38 degrees, okay, so that is 38. All right, and then they also tell me that the measure of angle MJZ, which I'm also going to try to find in my picture, M to J to Z, MJZ is this angle over here is 111 degrees. Okay, so that's 111 degrees. This one's 38. They would like me to find the measure of angle MZJ. So, okay, where is angle MZJ? MZJ, MZJ, that's this one here. So they want me to find this green angle, okay? So I have to think for a second about how am I gonna figure this out, and what do I know about the shape, okay? So I see 2 ways of doing this. I see 2 ways. Number 1, we can think back to the idea of parallel lines, right? Because there are parallel lines here because this is a parallelogram. I know that H to Z is parallel to MJ, right? These 2 are parallel to each other. So from parallel lines, back in a previous chapter, we talked about things called alternate interior angles, okay? So alternate interior angles in this particular shape look like this. If I know that this angle HZM is 38 degrees, then I know up here this angle is the same, because this and this are alternate interior angles. If you extended that diagonal as our transversal and then had our parallel sides, we have alternate interior angles. So this is 38 degrees as well. So now what I'm going to do is I'm going to take out the triangle in the picture, which I guess sort of looks like this, where this is J down here. I guess I can make it capitalized. That's J. And then this one over here is Z. And then up here we have M. So now okay, in this triangle, what do I know, right? What do I know about the triangle? Well, I know that here I have a 111 degree angle. And then up here I have a 38 degree angle. And I also know that in every triangle I've ever seen, the 3 angles all together have to make 180, right? And remember that this angle here, I guess I won't do it in purple. I'll do it in green, because the other angle in my triangle now is the angle they were asking me to find, right? It's this angle right here. So what I can do is I can simply do 180 minus 111 minus 38. Figure out what that equals, okay? That's perfectly fine. Now the other way to do this, if I just take this triangle and I move it off to the side for a minute, okay, that's this version. The other way I can do this is I can not worry about the parallel lines because I know they're parallel, but it doesn't really matter to me. And I can think about property number 3 of a parallelogram. And that says that consecutive angles, meaning the ones next to each other along a side, have to add up to 180, right? So that means this angle right here at J and this angle, this whole thing over here at Z, the whole corner Z have to be 180 degrees, right? Because they're consecutive angles along this side right here. So J plus Z has to be 180, okay? So what that tells me then is that the measure of angle Z, like the whole thing, the whole angle Z is gonna be, well, whatever 180 minus 111 is. 180 minus 111. That's going to be the measure of angle Z. So once I know that, then don't I just have 2 pieces of that angle here, right? Of angle Z, I have 2 pieces. One of the pieces is 38 degrees. That's the purple one they told me. The other is the green angle I'm trying to find. So once I have the whole angle Z, can't I just minus away the 38 piece that I know? And I will have the angle they want me to find, okay? So again, 180 minus 111, that's going to give me all of angle Z, and that's, by the way, going to equal 69 degrees. And then if I minus from that the 38 degrees for the piece that I know, I'm going to end up here with, what, 31 degrees. So 31 degrees is the measure of the angle they wanted me to find. Equals, a little smaller, easier to write, equals 31 degrees, okay? If you did this math, 180 minus 111 is 69, minus 38, again, is 31 degrees. So either which way you do it, you get the same answer, and we arrive at that angle being 31, okay? So that's sort of a more complicated version of what you might be asked to do. Look at a picture and decide, okay, how many degrees is this missing angle, all right? If you have questions about the properties of a parallelogram or how they could be used to find missing information, please do reach out to me. Otherwise, that's all I have for you right now, and we'll talk to you soon.